So, welcome. And again, apologies for not speaking Russian. I kind of feel bad. I learned Russian at school. I can understand some Russian, but sadly, I can't speak. So you're going to have to be listening to my poor English instead for the next 1 hour. So, if this works, it works. So the talk that I'm so happy you came to attend is called Decomposing Java Application. My name is Milen Dyankov. I work for a company called LifeRay. And out of curiosity, how many of you have heard of LifeRay? The company or the product? Okay, a few people. So one interesting thing about the company and the product, just as an introduction to the talk, and then I'll promise you I'm not going to talk about our stuff anymore, is that if you ask someone who has heard about the company and say what they do, they're going to tell you portals. And this is what we've been historically, like we've been in the area for I don't know how many years in the portals. But we shift from that to something that's more of like an application frameworks with ready-to-use services and stuff like that, which put me as a developer advocate in a situation where I need to explain to people what we do. And it turns out to be very hard to explain. And I'm like, people like, so what's your product? And I'm like, well, you have like this like framework with all these services that you can use out of the box, and it just speeds up whatever. And they go like, oh, services, are you doing microservices? No, no. Services like like you can connect to each other, not necessarily over the. Oh, you're doing SOA? No. Okay, so what I realize is we're struggling for a buzzword. If you don't have the buzzword to explain what you do, people don't understand these days. So this talk comes from the experience that we had with our big portal platform, which became too big to be maintained. We basically reached a point where changing something here results in something terrible on the other end happening, and no one knows why. And I'm sure none of you has experienced any of these problems, right? Right, that's what I thought, that we're unique in that. And so we decided that we're gonna split it into smaller pieces. And we like LifeRay portal and LifeRay platform these days is an open source product, so we split it in a bunch of other open source products. Some turn out to be successful, some not so much, but that's not the point. The point is what we discovered during the process was that we thought our platform is modular, well-designed. We've been in a portlets world where you have these hard constraints of class loaders and stuff. We've been following the rules for so many years, so it should be pretty easy, right? Yeah. Well, it didn't turn out to be very easy. That's one thing. The second thing is, I do a lot of consultant work. Not so much now these days when I do DevRel and community stuff, but like I have like 20 years of experience as a consultant. And then because of both jobs, I spend a lot of time talking to people who actually do software design, they write stuff and stuff like that. And one thing I realize is it doesn't make too much difference between how I talk to these people and how I talk to my kids. No, actually there is a difference. When I say to my kids, I use like, go clean your room. And when I talk to customers and developers, I basically say, this code maybe could be taken better care of. Yeah, that's the difference. What's the same is the answer. The answer is like, what do you mean? It's perfect. It's clean. I'm like, okay. So that's the subtitle, the second title of this talk is Cleaning and Tidying Children's Room. Because I think this is very similar. What happens in both cases is we are arguing over the meaning of a word. And in this particular case, that's the word clean. Like I say your code is not clean and you say it's clean. I say to my kids, their room is not clean, they say it's clean. Right? It's a perception, it's how you see things. Right? And then kind of came to me. I realized that, well, for as long as we argue about the meaning of a word, there's no way to move forward. And because we live in the microservices world, anyone brave enough to admit that they're not doing microservices? Thank you. So we're in the microservices world. Everyone's doing microservices. So you all know Conway's law. Anyone who does not know? Okay. So the Conway's law basically says that if you produce software, you're basically going to produce a software that represents the communication structure of your company. Now, okay, fine, I get it. But what came to me is really interesting is, what if I revert the Conway law? So if that's true, if Conway law applies to everyone, then I can flip it over and I can say that pretty much any software architecture can be represented as a company's organizational structure. Now, if you take that exercise, this gives you a very interesting opportunity to start explaining to people software architecture as a company structure, which is what I'm going to be doing during this talk. So hopefully, this way, you will understand the struggles that I have with explaining, architectural design, and maybe it's going to help you also explain it to other people when you need to. Everything I'm going to show you, because I'm going to show you a lot of code today, and I don't expect you to understand every single line of it. It's all on GitHub, in case you want to play with it. Later on, the point is to understand the composition part, or the decomposition part, like how things relate to each other, how they how they combine, and why they are separated the way they are, rather than actual lines of code and what this line does. So let's try that. Before we go to code, let me introduce you to a person, Hari. He's right there. So Hari wants to start a business. Assuming Hari is a student, for example, and he's like, oh, what business I should start? Maybe I'll start cleaning houses. Right? It's easy. I have my van. I have my tools. I'll buy some supplies. People call me. Go clean the cows. I clean the cows, get some money. Easy peasy. Let's start a business. Okay. So how that works for Hari? So the first approach is pretty simple. Here is my house cleaning example 1, and here is Hari. Can you read the code? I hope you can, yeah. So Hari has some stuff. He has cleaning tools, cleaning supplies. He has the van. He can do things. He can clean houses. Okay. So when you ask Hari to clean the house, he gets all the stuff, puts it in the van, drives to some place, cleans the house, drives back, and puts the income in some bookkeeping system. Straightforward, super simple. Well, Hari is also a person, though, and Hari can do other things. Like Hari can borrow a van. Like he has a van, so if someone asks, Hari can borrow it, right? But he doesn't borrow his van to everyone. He first checks if the person is his friend, and if it's a friend, then he borrows it. If not, then done. Same thing applies for borrowing his tools. Okay, so that's pretty much it. So on the client side, there's nothing special. I have this client class for pretty much any example. The only difference is who they talk to. And in this particular case, the client talks straight to Hari. So let's see how that works. No, I don't want a new file. I want to maximize this. Here you go. So house cleaning 1, I have a script to make things run easier. And this script accepts a parameter that tells which Java version you want to run this with. You will see why that's important later on. So we're going to run this with Java 8. Oh, and I have this client shell where I can talk to Hari, and I can say, hey, Hari, clean my house, please. And Hari says, sure. He puts the stuff in a van, drives to my house, cleans it, pays it. I pay him, he drives back. Works. Great. Super. Now I can say, Hari, can I borrow your van? I'm sorry. And Hari says, no, I don't know you. I don't borrow my van to anyone. I was like, what do you mean you didn't know me? I'm your friend. Like, remember? Oh, yeah, right. So he now borrows me his van. And then I go get the van, go on vacation, Harry's out of business, but that's a different story. So it's super cool. But then, for how long this business model will last? Like, I get it. It's actually a very good way of writing software if you think about it. Like picture bug fixing. Like that is the best way to write code in terms of bug fixing. Whatever goes wrong, you know where to find it. It's in here. It's this guy. That's Hari. Everything's in here. Whatever goes wrong, you go in this class, it's there. There's no digging into class, stack traces and stuff. It's all in here. So yeah, but that's what students do in first grade. That's how they write software. We don't write software this way. And the reason is the same why we don't structure companies this way. This just don't scale. You don't, Hari could only clean so much houses himself, right? So he goes like, no, I don't want to talk to customers anymore. I'm gonna hire Ronald. Ronald's gonna be doing the talking to the customers, and I'm gonna hide myself, right? So no one can talk to me directly. And I'm also gonna put all the van and stuff in the garage, and I'll hide the garage so no one can, go to the garage directly. Okay, so he changes the company organization. So here you have the Hari again. Here is Ronald, and Ronald is the one that customer's talking to. And you have this thing called garage. Actually, this thing's called smart garage. You know what? Because Hari did the research, and he realized everyone's using smart garages. And what they do, they allow you to do things like this. For those of you who don't see it in the back. Right? Yeah, so this is what's called smart garage. Like, Hari doesn't really need one of those, but everyone seems to be using it, so she got one. So this structure seems right. Okay, so let's try that. We'll exit that, and we go to house cleaning 2, and we'll run that. So same thing. Clean the house, that works the same way it used to be. Now say borrow the van. Hey, I just borrowed the van, Hari's out of business again. How the hell that happened? Right? He didn't ask me if I'm a friend or not. Well, it happened because of a thing that never ever happens in software projects. This. Right? Just because you're now not talking to Hari, you're talking to Ronald. Ronald was like, you asked Ronald to borrow the van, and Ronald was like, why the hell should I ask Hari? I have a direct access to the garage. You go grab the car keys, and you're good to go, right? Yeah, I know. This never happens in software, right? So Hari is like, nah, this company is not going to work that way. We need to change it. So he does some more research and comes out to this conclusion that a lot of people say that you should divide the companies in silos. So you have the front office, you have the company, and then you have the assets, right? So Hari goes like, yeah, that sounds like a perfect business model for me, right? So here's how, example 3. Now, we don't have everything in one big project, as in here, but we have separated it. So you have the front office, the company, the client, and the assets. So if you look into the assets, this is where you find, the garage. And hey, guess what? We also have the storage here and stuff like that. Then you look into the company. The company is where Hari is, and he also hired Andrei. So if you look in this here, now Andrei is also helping Hari, and he's hidden. No one can talk to Andrei besides Hari. So stuff is protected, right? So if you look into Andrei, where he is, you see Andrei is not publicly available to anyone. And then we have the front, where is the Ronald. I'm not going to bother you with any more code. You get the picture. So let's go back here, exit, clean, and then go to next example and run it. and see if we can clean the house. Yeah, business operates as usual. No problem with that. Can we borrow the van, though? Of course we can. No one cares. How the hell that happened? OK. Well, it happened because of another thing that never happens in software, which is this. All right? Yeah, you can't talk to Andre, but you can go straight to whatever you want. Like, yeah, I'm just going to insert this in a freaking database. Like, who's going to prevent me from doing that? Right? So you see where I'm going. Like, OK, the idea here is to put some stuff in control, but this clearly does not work. And then you'll say, like, but yeah, you're doing it wrong. Like, no one does software this way, man. Like, what you talking about? Like, who is building applications in this way? You and me. Everyone for ages. It's the universal BBC architecture that we've been taught for so many years. That's the only proper way to build software. Now, if you don't know if you've never seen that, it's because you've never seen it as a BBC. You've always seen it as a front-end business logic database, right? Or whichever other words you were told to be used. But if you're old enough, you know this was being put in our heads for many, many years as the universal way of doing things. But apparently, it doesn't work. So Hari needs to do some more research, more business company structure, stuff like that. So he's like, okay, no, we're going to change that. So we're going to shift things around. We're going to have the front office. We're going to have the company here, and I'm going to guard my garage and my van. And I'll leave the storage to Andre, and this is going to be Andre's single responsibility, right? OK, so fine. How does that work? Here's it. Example 4, so we have the back office again. We have the company here, and the company is Hari and the garage. I'm sorry, let me clean this. So Hari and the garage, and the back office is basically Andre and the storage and his single responsibility, and the front office is again Ronald. All right, fine. OK, let's see if that works. We need to exit here first. Let's clean this for you. Let's go to house cleaning 4. Actually, this way. And let's run that again. So, business processes first. Clean the house. Here you go. Works. Can I borrow the van now? Nope. Oh, wow. What happened here? Safeguard. Hari doesn't want to borrow the van. Nice. That's what we wanted to. Can I borrow the tools, though? Of course I can. Like, no one prevents me from doing that. Like, OK, why? How come this happened? Well, because of this. Now, Ronald, if he wants to get the van, he has to talk to Hari, and Hari's like, no. But if he wants to get the tools, all he has to do is talk to Andre. And Andre doesn't have any validation logic of you friend or not friend, or he doesn't know anything about it, right? You want tools? Get the tools. I don't care. They're not my tools, right? So, like, wait a minute. What are we doing here, right? No, of course not. I agree with you. No one does software like this. Except that this is what you've been told to do all the time, which is what I call the universal microservices architecture, and which is super cool when you start doing hello world stuff and things like that. And then at one point in time, you realize that you reach the point where each and every service has to talk to each and every other service in order to get things done. Right? Or you have to duplicate logic, like in this particular case, validation logic, or some kind of consistency logic, or whatever shared logic you have in your domain. You have to multiply this in every single service that you build. That's fine. It works sometimes, but as you can see, not always. So Hari is like, OK, I tried so many different ways to build this company. Nothing works. Like, what I'm supposed to do? And then someone tells Hari, you know what? You've been doing it wrong. All this time, you've been doing it wrong. Because what you do is you focus on entities. And this is not how businesses work. Business is not focused on entities. It's focused on processes. So it's not important whether it's Harry or Ronald or a van or whatever. It's important of what is it that you provide, what people can get from you, and what they get in return. So here is how you should structure your company. So you have your company, which has some stuff inside. And honestly, no one cares. Like when you go to a shop or when you order something from Amazon or a web shop, do you really care like how many people they hire, what's their revenue, and how they're organized? No. What you care is they offered me this good. I can order that. I can pay so much money. It's going to be delivered 3 days from now. It's the business contract. That's the only thing that you are interested in as a consumer. You don't really want to know what's inside in their company. It's the same thing here. We have things inside that no one cares about. And then we have things that people care about, and those are so-called use cases. So this is what this company provides to other people. And it provides cleaning services, clean house use case. And then you have an interaction point, which is the front office in this particular case, which can offer you one or many of these use cases and make it happen to you. Now, when you structure this way, now all of a sudden, what's in there becomes irrelevant. What is in here opens your project for future improvements, because later on, Harry can say, "Hey, you know what? I'm just going to be doing, cleaning pools, or I'm just going to be doing, I don't know, something else." With the same amount of resources that I have, I can expand the operations. Right? And no one needs to care about that. And the same thing is with the front office. He can say, I can offer you a different way to communicate with me. You don't have to come to the front office to put an order form. You can do it, through the internet or by phone or whatever. So you're decoupling the communication channel from the offer channel from the internal implementation, which gives you a lot more flexibility. And Harry is excited. He goes, yes, I'm going to do that, right? So here you go for the example 5. So we have the company, and the company is structured somehow internally. So you see we have things here like job positions, for example, because Harry finally realized it's not important whether it's Harry or Andrei or who. It's important that you have an accountant and an assistant and a cleaner, and those are definitions. They don't tell you how to do things. They tell you what you are, or anyone who is in that position is supposed to do, right? And then you have people, of course. You can say this, for example, Andrei is an assistant. So you know, just by calling him an assistant, you know what he's supposed to be able to do. And you can fire him if he doesn't. Same thing about Harry. Harry, for example, is a cleaner and an accountant, because why not? Yeah. Now, you decouple also the roles that you do. And you also have processes in here. So here is, for example, clean house process. A clean house process is a simple process. It basically says, grab a cleaner and ask him to clean the house. Or you can have a transport process. And a transport process is basically grab the van, load the stuff, put a driver in it, and drive to a particular place. Because you don't really care who is the driver. It's a process. It describes a process. So it's all super cool. And then in the use case scenario, you have like the customer use case here describes like a scenario which is clean customer house. And basically it says, well, in order to clean a customer house, you use these processes. You need an order process to process the order. You need to transport process to go there, and blah, 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 right? So let's see how that works. No, here, clear. Let's go to 5. and run this with Java 8 again. So the same thing. I've changed the interface here a little bit. We provide, so just to demonstrate you also the order checking. So no, we're not going to do for $10, but we can do it for $100. So here you go. The process works. It's great. Can we borrow the van? Of course we can. Like, no, man. Like, I'm done restructuring my company, and it's always the same thing. Why? Because of this. Because you said those things are hidden. You've explained to everyone they shouldn't use it, but you have a very smart people in your front office. They know better than you. They know that they can go and get them, even they're not supposed to. Things like some misconceived rings a bell. Like, you shouldn't use it, but why not? Okay, so is there a way to actually do something with that? Now you say, well, make those things package private. Well, if you make them package private, you can't use them from another package in the same company, which basically means you're restricting yourself to putting everything in your company in one big department package, whatever you want to call it. And this is not how companies work. So any ideas like how to deal with that? Well, we need to do this. We need to make sure those things in there, those in gray, are not available to anyone else but the people who are in that thing, in that company. How we do that? You can't do that with Java 8. You can do it, well, we'll go to that point later. You can, but it's a different story. But you can do that with Java 9 and any newer version of Java because of what was introduced in Java 9, which is the Java Platform Modular System, so-called JPMS. So the next example, 6, is code-wise exactly the same as the previous one, like logically the same, but it differs in a few ways. The first thing is we have in each and every module, we have this module info thing. And what we do here is, so this is the, let's start with the company. So we have a module info here, and we say, hey, guess what? Like job positions and processes and shared stuff are things that other people should know about. Whatever else we have in there is no one else's business. We don't want people to deal with that stuff, right? And it also tells you what it requires. So if you go to the use cases, it says, well, we actually deal with this company, right? So we need to use this module from the company, but we export use cases to other people. And if you go to the front office, for example, not his one, sorry, module info, it exports front office and it uses use cases only. Right? Even if I were here to, if I wanted to add here, require something from the company, I can still only require things that the company exports. So there is basically no way for me to go and get access to anything in this internal package because it's not exported, right? So I'm now effectively preventing anyone from accessing the things I don't want them to access. Okay, so how does that work? Let's go to example 6. And we're going to do something different here. I'm going to compile this, clean package, and I'm going to compile this with Java 8. And you'll see it compiles a few modules, and then I'm going to run it. And I'm going to say clean the house, it works. Borrow the van, it works. Like, why? Because Java 8 and every previous version of Java has no notion of modular system, they don't understand all this stuff, right? So yeah, you can do the same thing. Even though you've put the rules in place, you still have something that understands those rules and enforces them. Okay, so let's now compile the same thing with Java 9. Same thing works with 10, 11, whatever you want to try. And if you try to compile this with Java 9, you will be surprised because it doesn't compile. And if you look into like why, well, it's going to tell you that like company internal assets is declared in company, but the front office does not read it. And they're like, oh, wait a minute, front office, what you trying to do here? Like you're doing something you're not supposed to do. So you go to the front office in here somewhere. Front office, here you go. And look at their code. And it's like, aha, trying to get the vehicles behind my back. Sorry, man, can't do that anymore. Right? So they have no option but to actually not do that anymore. And because it's Java, I have to deal with the imports as well. So now they can't do this. Like the safeguards are in place, right? And if you go back and compile with Java 9, it's going to compile. And it's going to say, fine, I can do this because you're only doing things that you're allowed to do, right? And if I run this with Java 9 again. Okay, nothing like wasting time on stage. Okay, luckily it's something that compiles fairly fast. Where are you? Run. With 8, it's not going to work anymore. So with 9 on modular path. Clean the house. It still works. But if I do borrow something, it's going to say this is a not supported operation. And this is exactly what we wanted to do. We wanted to enforce the rules so people can only do the things that they're supposed to do and don't, overcome like the rules or bypass the rules and do stuff. And if you don't do this, this is where you end up in a situation where over the years of development, you reach out a product where touching something here makes something over there to explode, right? Because there's nothing that enforces the rules. And obviously, in these days, everyone would tell you the solution is put the network in between. Make it a REST service, right? And then you isolate. Like, what I'm trying to tell you is like all this microservices and RESTful services stuff is super cool, but it's not necessary to put a network latency and fallacies of the network computing in between your software pieces to make sure there is no unallowed things that happen. So, okay, that's super cool. Hey, 6 iterations and we finally get what we have. But you know what? You know what happens in production when you go in production? Things break. So it can happen to our van. It can break. And I have this properties file here that simulates a van failure. So clear. And let's do clean house again. What do you think is going to happen now? Boom. The van is broken. We have no way to go to the customer. And as you know, what businesses do in this case? The whole business shuts down, and we all sit and wait for the van to be repaired. Of course not. That's not how we operate. What we want is we want an alternative. We want a way to deal with that. But in this particular case, in this particular scenario, there is no way to do that. You have to shut it down. You have to fix your bug. You have to do whatever it takes and go back, right? So how do you fix that? Introducing services. No, not microservices the way you think of them, just services. like this. Introduce an abstract service layer where you can register a service, and if something goes wrong, you can pick a different service that does the same thing. Because when you start doing service-oriented architecture this way, you don't really care anymore who provides the service, for as long as you have someone who provides the service and fulfills the contract. So let me give you an example of the very same thing in plain Java. So close that. And we go to the example 7. So now in example 7, we have changed a few things. In the company, if you go here, we look at the process again. Let's take the transfer process. Now, the transfer process is no longer a solid process, but it's a definition of a process. And basically says, well, if you are a transfer process, you're supposed to know how to go to an address. I give you an address, and I put the stuff, I give you the stuff that you need to load, and you drive me there. And I don't care how you do it. That's my contract. I give you the address, I give you the load, and you drive me there, right? And then internally, because no one cares how that is implemented, we have internal processes, which is our local internal transfer process, which implements a process and describes how do we do it in particular in our company. In our company, we do it this way. We get our van, we load the stuff, blah, blah, blah. Now, what else we can do now is we can think like, what happens if our van breaks? Guess what? We can call Uber. Or I mean, yeah, we're in Russia, we can call Yandex, but the example is with Uber, sorry about that. But anyway, you can go to a company and sign a contract with them and say, can you do the same thing for me? And here is your Uber module in this particular case, which provides you one thing, the Uber transfer process, which is also a transfer process. It just works differently. You call them, they come, implementation details, like no one cares about that. What do you care about is how do you make the switch between one process and the other. And Java has this thing called service loader. How many of you know service loader in Java? Yeah, okay, it's getting better. Like to my surprise, service loader is something that was introduced in Java in version 6, and it's still like a lot of developers don't even know it exists. So in versions 9 and above, they changed the way you define those services. Before you had to put them in a properties files. Now they live in module info. So if you look at module info in here in the Uber transport, what it says is it provides a transport service, a transport process with a Uber transport process. And if you look at our company module info file, it says it provides a transport process with an internal transport process. So you now have ability to provide multiple ways of doing the same thing for as long as you have a contract that defines what the thing is. Okay, so how do you use that? Well, unfortunately, if you use it in a plain Java style, it's a lot of boilerplate. I'm just going to quickly show you here in customer use cases. So it kind of looks like that. You get the service loader instance, and then you load it, and then you have to find what you want. And it's a little bit of a boilerplate, but it works. It basically allows you to find the implementation of that process that you want. So that will work. The thing is, another limitation of the Java platform modular system is it's not dynamic. So you can't change these things on the fly. You have to tell it upfront what you want to have there. Well, that's not entirely true. You can actually do it if you are keen about writing layers on your own, and then you can have another module layer and another module layer. So there is a way to actually do it, but it's way beyond this talk. So for a very simple way of using the Java platform modular system, you just can't do it. So we're just going to say we want to run with all the modules that possibly we can. So we're going to add also our Uber module to the runtime. Okay, so now exit, clean. So let's go to example 7 now. Come on, here. And if I run this with Java 9 modular Java 9 on the modular path, I can do the same thing. I can say clean the house. It works. And I can break the van. And what's going to happen now is I'm going to be using Uber now. Because from my use case perspective, it doesn't matter. I use a transport process. Whoever provides me the transport process is fine. Now, if the van is fixed, if I find my keyboard, okay, I'll type it. And then I'll do this again. Now I'm going to use my van again. So I'm basically switching between process implementations on a fly. And if you think about it, if I was telling you this only about software, it's like, no, I never need that. But when I tell you about the company, you're never going to tell to me, no, our company is going to wait 3 days for the van to be fixed, right? So that's what I'm trying to do here, trying to tell you how things become important the moment that you don't envision while you write code. Okay, so there are two issues in here. Well, not really issues, depends on what you want to do. One is it only works with newer Java versions, like everything newer than Java 9 or newer. And the other one is non-dynamic. So you have to know upfront all the modules that you're potentially going to use and throw them in so they can. So when something goes wrong, you can replace them. There is another way to do this, and it's called Osgi. How many of you are familiar with Osgi? Okay, for those of you, how many of you hate Osgi? Yeah, that's what I thought. For those of you that hate Osgi, if we have enough time, which I think we may have, I'm going to show you exactly why you hate it. But for now, I'm just going to show you how to implement the very same thing with Osgi. Now, the difference in there is we don't have the module info and all this stuff, so it's backward compatible. It can run with Java 8. And instead of this service loader thing, what we have is we register our processes. Like here is a transfer process. I guess the same thing. And if you look at how it is implemented, processes, internal transfer process, we just registered it as an Osgi component. Now, I'm not going to go into details what that means. It basically means that there is a thing called service registry, which is similar to what service loader does in Java. And it just registered this thing there as an implementation of that interface. Basically, it tells this thing can do this, right? And on the consumer side, if you go to the use cases side, how you do this is like, here's customer use cases. You just reference a service, and it gets out-wired. Like if you're a fan of Spring or those things, and CD, like it's the same thing. CDI, Spring, whatever. It just uses a different annotation. As a matter of fact, in the latest Osgi release, you can use even CDI annotations to do the same thing. But for here, I'm just using the declarative services ones. So it's just this, it's basically the only difference is how you register a service and how you get a service. Everything else pretty much the same. So when I have this now, I can now go to house cleaning 8. And run it again with Java 8 this time. The show is going to be a little bit different as the standard Go-Go show that comes with Osgi, but basically that allows me to do the same thing. So I can do clean house for €100, and here it goes. Okay, let's break the van. 8 status, here you go. The van's broken. Clean house. I can't go there. No van. So what I'm supposed to do? Well, I'm going to do install. And I'm going to go to my Uber transport in here, find my jar file, drag and drop it here. And then I say I say, show me what's in my runtime. Hey, my Uber transport's here, but it's not started. Let's start it. Okay, that's what you get when you play with your code just before you got on stage. Yeah, I told you I'll show you why you hate it. That's why. Because I need to recompile this. Because I was playing with something else. Okay, MVN clean package. Okay, let's run this again. Let's see what's inside. I restarted, so I don't have the module in there. I'm gonna grab it and install it now. House cleaning Uber transport. Here it goes. And what's inside? Hey, I have it. Up, started. And if I see what is it there again, you can see that now I have a Uber transport active, right? So clear this again. So if I go clean house for €100, now I go with Uber. And if I fix the van, I go with my module again. Yeah, I was supposed to restart that, but stupid mistake. Anyway, the idea here is you can do it dynamically. You can just install something on the fly when you need it. And this gives you a lot more flexibility in terms of how do you deal with production systems. And if you think about it, it's exactly the same thing what you do with microservices these days. Is like and the reason why you are most likely using microservices, besides all the polyglot and all these other things. But at the end of the day, what you have is you have a small amount of functionality, another small amount of functionality, and you put a line in between them, which is the network. And you tell them, you talk to each other over a network protocol, REST, whatever, right? And then what happens is, you hope, they're never gonna fail all at once. Like one will fail, but if it fails, it's fairly easy to replace it. And hopefully you've done it in a way that this other thing can deal with the failure of that of the other stuff, right? The whole thing of microservices is this, resilience, right? Small pieces of software that are resilient to failures and stuff like that. Well, this is exactly the same thing without the networking overload. You build components and isolate them and well-define them. It's like, this is what you can do, this is what you cannot do, and this is how you behave in terms if a failure happens, right? So mental model is the exact same thing, except here you just have it all in one virtual machine. And if you build it this way, it's much easier later on to just grab this piece of software and say, okay, you know what? I'm just going to isolate you even further. And now instead of you being isolated inside the Java virtual machine, you're going to be isolated inside a Docker container or inside a whatever else virtual machine, right? But the mental model behind it is the same thing. It's isolation, single responsibility. You know what you can touch and what you cannot touch. Okay, so the short version of this talk ends here, and because we have more time, and the organizers tells me that here's like a lot of people that want to go deep into things, I have a few more things to show you. If you lose track and stop understanding what I'm talking about, that's fine. You've got the main message. Okay, so that's all fine what we did so far. The problem with that is what we did was a conference talk, I'm on stage, I can do whatever I want, I can change code and run it again, no one cares, right? And this is my fundamental problem with conference talks in general, because you watch these guys do all this stuff, and oh yeah, I'm gonna do that. And then you go home and it turns out, well, when my stuff's in production, I can't just change code and do stuff in production like this, right? So in here, I just change code and compile and goes, right? But now let's assume let's assume this version of the application that we have is already in production. And we have signed a bunch of contracts with a bunch of companies that are providing, that are requesting cleaning services, right? So this, let me go back here. So this goes in hundreds or in thousands, right? And they talk to us, and then we have a bunch of process implementers and stuff like that. I can't simply go and say, oh, guess what? I'm just going to change the code and deploy. Boom. Oh, your service is not working, but it's your problem, right? It doesn't work this way, right? So is there anything that allows you to actually control that side of things? And in OSGI, there is something, and I told you, for those of you who hate OSGI, I'm going to tell you why you hate it. This is why you hate it. Because it allows you to safeguard changes. It tells you, like, no, I can't change that, because if you do this, you're going to break people. And people is going to be mad on you. And when someone tells you can't do this, you get mad on him. That's why you hate it. And I'll show you how that works. One thing that you have in OSGI is package versioning. So if you look into my company code, and you look into my process here in package info, you'll notice that I have this thing annotated as version 1.0. So basically what I'm seeing here is this package is at version 1.0, and now you're going crazy like, what, versioning packages? Yes. And you'll see why. Okay. And I also have the standard Maven stuff. So what's going to happen, and I also have another thing. Let's go to my transport process. I have this crazy annotation here which says provider type. Like, what does that mean? It means this thing is a provider. It's an interface that has to be implemented by whoever is providing the service. It's not something that's used by the consumer of the service. Why is that important? Let's add a method here. We add a method here. We obviously need to implement that method in our internal process. And because we are in production, we can't just recompile the same jar file. We have to bump the version. And because we have a package version in here, we also bump the package version. So it's going to be 101. OK, and we're going to bump the version to 0.0.2 snapshot. All good, right? That's what we normally do. We release a new version of the same jar file with a change functionality in it. So let's go and compile this. Okay, now I need to get out of here. Okay, so I'm in house cleaning 8. So I'm just going to compile this again. Let's see what's going to happen. Now, I can't compile the company anymore. Like, why? Well, if you look into it, it says it detected a minor change in the code, but I have a package update. This is what OSGI heavily makes use of. It's called semantic versioning. It enforces you to do a semantically correct operations when you do upgrade. You don't have to check this at build time. I have a plugin that I enable this to do the check at build time. But if you don't do it at build time, it's going to do it at runtime, and it's going to yell on you the same way it yells here, right? And this is where people get frustrated. It's like, what the hell? Like, you know, I just want to throw a jar file and make it work. No, because if you do this, it may work today, but you're potentially going to break tomorrow. Okay? And so it tells you what you should do. So if I go, oh, great. Now I need to figure out how to, Mac. Okay. So what it tells me is I need to do a minor version upgrade here. And it also tells me I need a minor version here. So if I do this, and come on, and I compile this again, it should now work. And now tells me, okay, that's fine. You've changed the version in a proper way. Now, I can do the same thing within the say use cases, which is here. And in use cases, I have this interface, which is no, sorry, not in use cases, but in the front office. I have this interface, which is called order form. Now, where am I? No, the wrong example. Front office order form. Where? Why? Oh, no, but yes, wait. Use cases. Cleaning request. Okay, that's what I wanted to find. So I have this interface called cleaning request, and in here I say it's a consumer type. Now that's different because it means it's going to be used by consumers, the people who call me, right? And why is that different? Because if I make a change that breaks providers in here, chances are it's only going to break one or two of my providers. In this particular case, it's only going to break Uber provider. But if I change a consumer interface, it's going to break everyone. And so if I do this here, and if I change this here, I don't have enough time to do it, but if I do it, I'm going to get the same complaint, but it's going to tell me that I need to do a major version upgrade, right? And those are the things that also are guarded at runtime. Right? So it not only tells you you can't do this, you can't do that in one modular way scenario, but it also tells you how you can upgrade or cannot upgrade. Okay, so this is what we ended up doing, and I'm back to the thing that I started with, naming things. I think that's the fundamental thing that we have issues with these days, is people stopped, in my opinion, most people that I talk to, sadly, stopped trying to understand what's behind why we do this way, why we do that way, and they started dealing with buzzwords. Oh, we do microservices, we do Spring Boot, we do, like, that solves the problem. It may or may not. So it's not about buzzwording, it's about understanding what it is that we try to achieve by using that word or the other word. And if you think about the cleaning rooms, it's the same thing. Like, why would you tell your kids to clean the room? Is it because you just want to give them more work? No, because you want them to live in a safe and livable environment. You want them to not get hurt. You want them to be in a clean place. That's the goal. It's not the definition of clean. And it's the same thing with software engineering, software development. You want your code to be a safe and livable place. That's the goal. Thank you.